Hey everyone, it's Christina from the Glazer Tutoring Company. Today it is a dark, rainy day, and what better day to do some videos and to solve systems of equations by substitution. Oh yeah. This one's going to be fun. We're going to learn how to solve these systems by the substitution method. Now, a system of equations is basically just two equations, two or more, right, that are interacting with each other in some way, right? So these collectively is called the system. Now, the whole question here is that we just got to solve the system. Well, what does that mean, right? If you're solving a system of equation, whether you're doing it the substitution way, there's an addition way, which I think is called the elimination way as well. You're solving for that point in which these two lines interact. These are both linear lines because they don't have any squares next to the x's, no cubes to the y's, it's just 1 and 1. So linear lines, and to solve them, you're solving for the point where x marks the spot. Yay. How fun. But anyway, you're just solving for that point, right? And the point consists of x and y coordinates. So ultimately, you're just trying to solve for what x equals and what y equals when they both are at that same point. Now, when you're doing the substitution way, the first thing is that you have to get one of these equations into either x equals or y equals. In theory, it does not matter which one you choose, but little tip and trick here is that you should choose the one that just has, a 1x next to it, so it'd just be like x plus something, 7y, or, same thing for the y's. So, I see the chosen one. You are chosen. Because this is just a single x, right? Which means I don't have to do any division to get x equals. So, if I'm going to label this as equation 1 and equation 2, what I'm going to do is I'm going to take equation 1 and just solve for the x equals. So, let's do that. So, we have x minus 0.2y equals 1. So, you want x equals, you got to move the y's to the other side. So, plus 0.2y plus 0.2y. How easy is that, right? This gets canceled out. Goodbye. And let's put a little line here and say that now x equals 1 plus 0.2y. And now we have the first part done. We now know that the x value is going to equal 1 plus 0.2y. Now the second part is super important because if you use the first equation to find out x equals or y equals, you can't use the same equation again because then, for this next part, because then your answers are just going to come out to being 0. You're going to lose your variable. So if we used equation 1, we have to now use equation number 2. So enter in equation number 2, negative 10x plus 2y equals 5. And here comes the substitution part. We're going to take our x, find it on here. Here's the x value. And we're going to pretend that it's like a substitute teacher, right? If you have a substitute teacher, it's not usually there all the time. Your real teacher goes out and the substitute teacher, boop, kicks in. But just be careful because this negative 10 is being times by the whole x value. So when I plug in the 1 plus 0.2y into this, you have to make sure that you put parentheses. So this is going to be negative 10 times that whole value of what x equals, right? So essentially what you're doing is just plugging that in. So 1 plus, I don't like that 1. 1 plus 0.2y. And now just continue on with the rest of your equation. Plus 2y equals 5. Now we got some distributing, it looks like, because now we only have that one y variable. No more x's anymore, so you could solve it just like any other equation you solve. So we have negative 10 times 1 is a negative 10 minus 10 times 0.2. Well, 10 times 2 is 20. You move the decimal over, so this would be 2y. And then plus 2y equals 5. This one is interesting. I already see that there's a little bit of an issue here, right? Negative 2y and plus 2y. Let's just see. I just want to make sure. Negative 10 times 0.2. Yeah. Now, this is interesting because we followed the rules, right? We use the first equation as one. We use the next equation as the other one. But look what's going to happen, guys. When I, simplify, combine like terms, what happens to the y's? Negative 10, this cancels out, right? Negative 2 plus 2. And I just want to make sure, yeah, this was a plus 2y. And this was a negative 0.2. So this had to become a positive. I'm just triple checking. Always good to triple check. And then this one was a plus. That turns into a minus. Yeah, okay. So we're going to stick with it. And we're going to say that these cancel out. But now, now we're just down to this. Does this make any sense? This doesn't make any sense. So this is not a solution. You lose your variable. But that doesn't mean that we did it incorrectly. The question asked for solve, right? And if these two equations were crossing paths, there should be a point that they both have in common. But if I just lost my variable and negative 10 equals 5, that doesn't make any sense, right? This is a big X. This is a big no-no. That means that do these lines come into contact with each other? No. So they might be parallel lines and they never cross each other, which means that there will not be a point that this line has the same because they never touch. So by us trying to solve and we, lose our variable and we say that this, negative 10 doesn't equal negative 5, we actually did get our answer because there is no solution for this one. And sometimes that might happen. There's been a lot of tests in my academic career where, they would throw you some trick questions and, in math and in other other classes where the answer is no solution. So in this case, we tried to solve, but there's no solution because they don't cross paths. And that's it. What'd you think? I hope this helped. Thank you so much for viewing the video. Subscribe to the channel, and I look forward to helping you in more problems. If you want, we opened up memberships on the channel. There's 4 different tiers. If you guys want to help the channel a little bit out more, thank you for your kind consideration. And yeah, I'll talk to you soon, okay? Have a great day. Bye-bye.